attention. All right. Again, the final on Friday is pretty important because I don't even think we have school the following Friday. Does anybody know?
Yeah, we don't have school.
We don't. So I don't have any more opportunities. All right. And again, I'm looking over the grades. The grades seem pretty good, but some of you I know want to do a little better. So please work through this. All right. Make sure you know it. This is a huge unit. All right. That will help you understand numbers better. All right. So here we go. Question number 1. We should be able to fly right through these. Hey, we should be able to fly right through the odds here. All right. Again, the difficult ones are the word problems, so let's try to get there as quickly as possible. All right. Number 1 was 7x cubed. If you're not sure, you can let me know. All right. Number 3. Now remember, we broke down 32 so many times. You should be able to see that's 16 times 2, which we pull out of 4. So that makes it -8. Now, at this stage, we've done it so much, I would like for you to be able to look at t to the 5th and say that's just t times t to the 4th, or that you can pull 2 groups of 2 out. So you would have t squared radical 2t. Now, does anybody have a question with that? No questions? Yes.
Wait, so you do it 2 ways for the pulling the teeth out? In groups of 2, or what did you do?
Did you get that answer?
Yeah.
Then we're good. What?
I just got a -8t and then 2t squared.
No, t to the 5th is t to the 4th times t.
Yeah. That's what I did originally. So the first one is correct.
This is the right answer.
Okay.
I'm used to putting up the wrong answers for everybody, okay? Thank you, Emery. All right, here we go. Now we're breaking down 18. Again, 18 is 3 radical 2, but there's a 3 already out there, so we're calling that 9 radical 2. 8 is 6 radical 2 plus 20 radical 2. All right, if you're not looking at that pretty quickly, you're just behind. All right, does anybody have any questions with that? All right, now, of course, we're going to simplify that to what? 23 radical 2. All right. Now, yesterday, a lot of people asked me about number 7, and I'm not real sure why, because if you had issues with this, you could always break it down into the square root of 21 over the square root of 16. But I was hoping you would just look here and say, the 16 is under the radical, so the square root of 16 is what? 4. All right? Now, we can't do anything with the 21, so it's just the square root of 21 over 4. That's all there is to it. You don't have to rationalize. You don't have to do anything. You have to simplify. All right? You have to simplify. All right? Now, in question number 9, I was hoping you see that there was a common 13 here. So it should be 13 radical 3. Well, there's 2 13s, that's why. You pull the 13 out. There's this 13 and this 13. That comes out as a 13. All right? Remember, square roots means you're pulling them out in groups of 2. You're pulling them out in groups of 2. All right? Now, question number 11, you're distributing a square root of 5. When you distribute a square root of 5, when you do square root of 5 times square root of 5, of course you know that the square root of 5 times square root of 5, you should say is 5. And then 5 times 3 is 15, and then minus exactly 2 radical 5. The reason why we say it's minus 2 radical 5, remember the 2 and the 5 don't combine because they're not both radicals. All right? Very straightforward, very easy. All right? Now on number 13, I think some of you guys have this down. 3 times 2, again, is 6. And then your smiley faces, I have 2 radical 5 and 12 radical 5. So that gives me what?
14 radical 5.
Yes, that gives me 14 radical 5. So it'd be plus 14 radical 5. And then, of course, we're doing the square root of 5 times 4 radical 5. And radical 5 times radical 5 is? 5 times 4 is?
20.
Right, so it'd be plus 20. So then 26 plus 14 radical 5. All right, now for 15, if you recall, I would like you to look here and say that the middle term cancels out. Does everybody agree with that? Right, so 2 times 2 is 4. Square root of 3 times square root of 3 is 3. So 4 minus 3 equals 1. And again, just remember the plus times the minus. That's the reason why it's a negative 3 there. All right. Okay, so look, very good for you, Drew. So if I multiply radical 3 times 2, that's a positive 2 radical 3. Yeah. And then if I multiply these two together, that's a negative 2 radical 3. All right, so you got to be careful with the sign. You got to be careful with the sign. All right, now 15 again. All right, these do not cancel out because it's not the same. All right, so 1 times 2 is 2, and then I'm going to do the smiley face. So I have negative 6 radical 5 plus 3 radical 5, which gives me what? Negative 3 radical 5. And then, again, we'll just take a look. Negative times a positive is a negative. And then we're going to have 3 times 3, which is, and then radical 5 times radical 5. 9 times 5. All right, I think we're getting the hang of it. And then 2 minus 45 is negative 43 minus 3 radical 5. Yes. Okay, so again, we did the smiley face, right? So let's do this again, just to make sure. All right. So we did these two multiplied together. Very good. So I'm going to put negative 6 radical 5 here. All right. Now I'm going to multiply. These two together, and that would give me. I'll give her a positive 3 radical 5. You with me on this? That's why it's negative 3 radical 5. Everybody good? Okay. So, good. What? Quick. Okay, let's talk about 45 again. All right, so again, super important. These two things are being multiplied together. Do you agree? So I'm multiplying 3 times 3, which is now square root of 5 times square root of 5. Right? Square root of 5 times square root of 5 is 5. 9 times 5, 45. Good? All right. Now again, in my opinion, you should always, when you see fractions, the first thing to come to mind should be try to reduce them. All right, so I'm looking at is 21 divided by 3. What's 21 divided by 3? 3. Square root of 5 divided by the square root of 20. Square root of 4. Right, does everybody see that? All right, you can reduce fractions. Reduce the numbers, reduce the radical. All right, now what's the square root of 4?
2.
So the answer is just 3 over 2. Now that was a problem for some people yesterday too. Does anybody have any questions now with that explanation? 21 divided by 7. No, I didn't. There's no chance I said that. Listen again tonight. You'll see. You're wrong. 21 divided by 7 is obviously 3.
Should we quote you on that?
Yes. All right. Something might happen to the video, but I hope not. All right. Square root of 45. Obviously what?
9 times 5.
Which is
3 radical 5.
3 radical 5. Beautiful. And then x to the what?
4.
X to the 4th. Easy as that. Easy. All right, 23. Here we go. To undo a radical or a square root, all you do is square both sides. So x is equal to 64. X is equal to 64. All right. 25. All right. 3 radical x equals 9. Radical x equals 3. X is back to 9. All right. Now that's how I would hope you would be able to see it. All right. First of all, you're isolating the radical. All right. And you're just doing the opposite or the inverse of each operation. So you're undoing subtraction, so you added. You're undoing multiplication, so you divided. Then you're undoing a radical, so you squared. Do you have any issues with that? Michael, you with me? All right, 27. Now, some people had a problem yesterday. They accidentally added 1, or the radical is already isolated. So I have to get rid of the radical right away. So I'm going to do what? Square both sides. So now I have 2x minus 1 equals 9. 2x equals 10. So x equals 5. All right? Any issues? Yes, sir. Good.
How come the numbers didn't change when you squared 2x minus 1?
Very, very good question. Very good question. All right, because look, now try to think about it like this. This right here and this right here do what to each other? They cancel each other out. All right, let me give you an example of that, all right, which I think is important. All right, so if I had 3 times 2x minus 1 equals 6, I can say 2x minus 1 equals 2. Do you agree?
Yeah.
Because I just did what? Divided by 3, right? So none of this changed, right? Because I undid the multiplying by 3. All right? All right, continue. 29. Now it's not isolated here, so I have to do what? Subtract 4 from both sides. So I have the square root of x over 2 equals 5. X over 2 equals 25. So x had to be what? X is 50. Yes, ma'am.
I'm confused because I don't want to square.
Okay, so now listen to me. I need you to understand what I mean by isolate the radical. This radical is not isolated because there is a what? There is a 4 next to the radical. I'm showing you up here, this radical is isolated. The only thing that's there is a radical. Previously, just watch. Previously, the radical is what needs to be isolated. So there's a negative 2 in the way and a 3 in the way. You see what I'm saying, right? You're trying to get the radical by itself. The radical here is by itself. So I just undo the radical. All right. On this problem right here, I had to eliminate the 2 and I had to eliminate the 3 to isolate the radical. All right. Same thing here. The radical is already isolated. All right. And on 29, the radical is not isolated. Yes.
So how'd you get 25? Like you square it?
Yes, exactly correct. Square, square.
Oh.
Because to undo a radical, you do the square. And I always try to tell kids, if you look at your calculator, the keys are grouped with the inverse. All right? So all of the calculators on your calculator, if you look at the calculator, there's weird looking numbers on there. Well, those are math operations that you don't know about yet, but you will soon. They are grouped as inverses. All right, just like adding and subtracting, multiplying and dividing, square and square root, cube and cube root. All right, they're all grouped together. All right, so now, here we go. The fun begins. All right, now again, some of you guys, I'm a little disappointed yesterday because you were whining about this without doing much thinking. All right, so the exact area of a rectangle. Well, in order to find the area, you had to know what the formula was. And the formula is length times width. All right? So your area is simply the square root of 6 times the square root of 3 And you see there's a common 3, so your answer should be 3 radical 2. That's all there was to 31. Now, I know we didn't have to do 32, but the formula for area of a triangle is, just to remind you, 1/2 base times height. All right, if you don't know that formula, I'm telling you, just go on your iPad and use what it's there for. Google area of a triangle, and it'll pull the formula up for you. All right, what?
Well, I don't get how you got 3 radical 2.
Okay, let's say I didn't know. What's 6 times 3?
18.
How do I break 18 down? No. 6 is not a perfect square, and 3 is not a perfect square.
Oh, 9 times 2.
There you go.
Oh.
But listen to me. I want you to be smarter than that. 6 has in it a 3 times 2. So there is a common 3 in each of those. True? So that comes out as a 3. All right. Now, this is the one that just threw everybody for a crazy loop yesterday. Find the length of the side of a square whose diagonal is 8. So to me, I'm not expecting you to know how to do it necessarily, but on your paper, I should probably see some type of square drawn. All right, that would benefit. All right. And then it says the diagonal. The diagonal is 8. Come on, you should have at least done that. All right. Now, a square with a diagonal creates a what type of triangle? A right triangle. All right. And so we've been worried about, or been working on, the Pythagorean Theorem. All right. But what's true about each of the legs here? They're equal because it's a square. So you should be able to write this is x and this is x. All right. So then when you're using a squared plus b squared equals c squared, x squared plus x squared equals 8 squared, 2x squared equals 64, x squared equals 32, so x is 4 radical 2. Come on. I don't know what you mean.
Like how oh, because 32 is 60.
But how do you know like when to use the a squared plus b squared plus c squared?
Okay, so listen, I don't want you mad at me, but I'm honestly, I'm thinking about the problem. I can't say you always do this. That's what people want. You have to read the question and figure things out. All right, that's very difficult. All right, so there's no just here's always do this or always do that. All right, that's why kids hate word problems. They just want algorithms. Just show me how to do it step by step. All right, and the objective is for these word problems to try to get you to think about all the information that you know and use it. All right, that's why it's hard. All right, 35, just like here. Annie is pulling on a 60-foot rope attached to the top of a 48-foot tree. So there's my tree. All right, there's my rope. And this is 48 feet. The rope is 60. How far from the base of the tree is she standing? This is X. So trees generally grow at what? Right angles. That's why we can use that. All right. So we're missing the leg. So in this case, we would say x squared plus 48 squared is equal to 60 squared. All right. And if you solve that out, I believe x comes out to be 36. Do they agree? All right. So x is 36. All right. Now, hopefully you remember what I told you. I want you to write this down again. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Now, how did I know it was 36? I knew it was 36 because this is 12 times 4. This is 12 times 5. So this had to be 12 times 3. Exactly. All right. Those of you guys who are wanting to get better at standardized tests, you think that's important, then you would try to remember those. All right. You would try to remember those. All right, for your standardized tests. All right. It's very, very helpful. Very helpful. Especially now on some of your entrance exams, they don't let you use calculators. Right? Well, they don't let you use calculators because they want to see who knows that. All right? Because it's a big waste of time to do 48 squared and 60 squared. All right, subtract and then take the square root. All right, so let's look at 37. A circle inside a square. Okay, so again, I was a little mad at some of you guys yesterday when you started saying, oh, I can't do that, it's so hard. All right, so let's look at, see how really hard this is. All right, so we try to draw a square, and then we try to draw a circle that's inside the square. All right, and as we're doing this, all right, if the area of the circle is 196 pi, so area of a circle you should know is pi r squared, so 196 pi is equal to pi r squared. So the r squared is equal to 196, so r had to be what? 14. So the radius of the circle is 14. Even if I had no idea, and they said the area of the circle is this, the only other information would be, well, the only thing I can find from that is the radius. So then I would draw the radius. And I would draw the radius so it would help me. So if that is 14, then from here to here would be what? 14 also. So the side of the square is actually what? 28. All right? That's all there was to that. Yes?
So when it's 196 pi, exactly, it has to be multiplied by pi.
Exactly correct. Very smart. And when you get to advanced math, we just leave answers in terms of pi. We don't use 3.14. Just like we don't say the square root of 2. All right? We don't estimate that. We just leave square root of 2 alone. Yes?
When you bring the 196 pi over, where does the pi go?
It's really simple. Watch. 196 pi is equal to pi r squared. Divide by pi, divide by pi. Pi's cancel. All right, that's it. Any questions? Well, no, that's not that hard. All right, it's really not that hard. All right. So let's look at 39. 5 times the square root of a number. 5 times the square root of a number is 625. Do I agree with that? Yep, you have to divide by 5. So the square root of x is equal to 125, right? And then when you square that, what does that come out to be? Because to undo the square root, I did what? Squared both sides. Any issues? All right. Now, for the next one, all right, I just want you to look at 40 because I don't want any problems. All right. This is an actual distance formula. All right. So this is the first point. So we label this x1 what? y1. And this is a second point. So this is x2, y2. So just plugging those numbers into that formula. All right. That is a great little formula. I'm not asking you to memorize it. I'll put it on the exam. If I decide to put that question on, you'll have the formula. All right. But it's just another formula that uses what? Radicals. All right. Now, on 41, it says the length of the side of a square, or find the length of the side of a square if its area is the same as the area of a triangle whose base is 12 and 30. All right. So, area of a triangle is equal to what? 1/2 base times height. So let's figure out what the area of the triangle is. 1/2, what's the base?
12.
12. And the height is what? 30. All right. So what's half of 12 times 30? The area of the triangle is 180. correct? All right, so that's the area also of the what? Square. So the area of the square is 180. And what's the formula for that? Length times width, or just side squared? Now the reason we call it side squared because the length and width are both what? The same. Right? So if you don't like s, which I totally agree with, 180 is equal to x squared, and then you just do what? Take the square root of both sides. And who remembers what number I said 180 was? What did I- 30.
36 times.
Yeah, wow, look at you. 36 times 5. 36 times 5. So x is equal to 6 radical 5.
Why did you take the square root?
Well, because the area of a square is side squared, right? Because we're looking for, it says the length of the side of the area of the square is equal to the area of the triangle. You agree with that?
Yeah.
So the square is 180,
Oh,
right? So I have to find the side of the square whose area is 180. All right, 43. It says the bottom of a 25-meter ramp is, well, what's the answer here, guys? Without doing any work. Look at your triples. Look at your triple.
7.
Your height is 7 meters and you're done with the problem. All right. Now, of course, most kids don't remember that. So let's draw it out. All right. So here's a ramp. And usually your ramp is constructed to form a right angle. The bottom of a 25-meter ramp. Well, that would be 25 meters. All right, is 24 meters away from the base. So that's considered the height. So it would just be h squared plus 24 squared equals 25 squared. Everybody good with that? Everybody okay? All right. Number 45. When 5 is subtracted from 2 times a number, the square root of that result is 8. So what do I do to both sides? Square both sides. So 2x minus 5 equals, so 2x equals 69. So x is equal to, just leave it as a fraction, 69 over 2. Any issues? All right, 47. The search for a missing boat covered a circular region with an area of 200 kilometers. What's the radius? Well, that's just telling you what? Area equals pi r squared. 200 equals pi r squared. So r squared is equal to 200 over pi. And then what do I need to do? Take the square root. All right. So the approximate radius would be, and you just type in on your calculator, the square root of 200 divided by pi. And what was that? 8 something? What is it? Come on, 200?
Yeah, it's like 8.
Is it exactly 8?
No, it's 7.9.
Yeah, 7.98, somewhere around there, kilometers. All right. Now again, the only way you know that is you have to type it in on your calculator. Don't just write down my answer because I say that's the answer. Take out your calculator so you know how to do it. Do 200 divided by pi on your calculator and then take the square root of the answer. All right? It's a lot easier just to write my answer down, but you got to double check. Make sure you know how to use your calculator. All right, here we go. The formula S equals 4.9 t squared is an actual formula, believe it or not. It gives the approximate distance traveled in t seconds by an object falling from rest. How long does it take the rock falling from rest to travel 2,000 meters? All right, so 2,000 is equal to 4.9 t squared. That's all there was to it. First thing I need to do is do what? Divide by 4.9. So t squared is equal to, somebody tell me what that is.
408.16.
Thank you, 408.16. Then we just take the square root of that. So t is roughly what? 20 point what? Yeah, you guys waiting for me. There's one on your iPad.
20.2.
All right, about 20.2, and we say that would be in seconds. All right, so after 20 seconds, the object would have fallen 2,000 meters. All right. Yeah. All right, 51. Again, on 51, I would like for you to put x1, y1, and then x2, y2. Now remember, the x1 and y1 are called subscripts, and that's just showing you that that is the what? That's the first point, and the other one is the what? Second point. All right, so now your formula is distance is equal to the square root of, you subtract the two numbers. So it's going to be 7 minus, and then what? 7 minus a negative 5. Yes, so just put 7 plus 5 squared plus negative 9 minus 3 squared. All right, so here we have distance is equal to 12 squared plus negative 12 squared. Now, please watch this because I'm trying to help you with your numbers now. It's a very nice thing to know. 12 squared is what? 144. Now, please watch, so this could be easy for you. It's 144 plus 144. Does everybody see that? Does everybody agree I have 244s?
So it's just 2 radical.
So it would be 12 radical 2. Good. So it'd be 12 radical 2, because I want you to look at that, please, as there are what? 2 144s. And then the square root of 144 is what? 12. So it'd be 12 radical 2. I don't want you to say 144 plus 144 is 288. And now you're trying to figure out how to break down 288. When you can recognize right off the bat that what? 144 is a what? Perfect square. All right, hopefully that makes sense.
144 minus 144. It says 12 squared plus.
Look right here, buddy. Because in the formula, you're adding the squares. You with me?
But how does that like change?
Because a negative squared is a positive.
Oh.
Agreed?
Yeah.
That's why you have to put it in parentheses. All right? Okay, so 53. State whether or not the three given numbers could represent the length of the side of a right triangle. All right? Now, remember that C is always the largest. So 30 is C. All right? So here we go. 10 squared plus 20 squared, does that equal 30 squared? 100 plus 400, does that equal 900?
No.
No. All right, no, that is not the sides of a right triangle. Exactly right. All right, here we go. Now we're into the SAT, ACT kind of questions. All right, a little bit harder. All right, what did I tell you about isolating first? So what's the first move here? Minus 10. Very good job. So now, just because you come to something you don't recognize right off the bat, don't just say you don't know how to do it. Instead of a square root, that is a what? Cube root. So how do you think I undo a cube root? You cube it. That's how simple. All right? So this is cubed, cubed. So we have 3x minus 9 equals 27. 3x is equal to 36. So x is equal to 12. Easy, easy as that. All right. Let's take a look at 57. It says, what is the length of AC? So because we have iPads, this is very beneficial. So I'm going to draw AC. And what do I notice? It creates a right triangle. All right. So now the hard part, please pay attention. What is this distance from here to here? Everybody look at that carefully. Now remember, we're moving left and right. We're moving left and right, so what's moving? The x. So I started at -1 and I ended at 4. So how many did I move?
5.
5. Come on now. These are always on all standardized tests. That's a 5. All right. Now I'm moving from B to C. So what's changing? The y value is changing. So I moved up how many? 3. Look how simple that is. All right. And so now I'm looking for the hypotenuse. So 5 squared plus 3 squared equals c squared. 25 plus 9 equals c squared. 34 equals c squared. C equals square root of 34. All right. E. Yes. I counted from -1 to 4. Looks super important. Pay attention. There's there, and I ended there. I went from -1 to 4. You hear me? Super important problem. All right, 59. Okay, we need to find the perimeter, correct? Everybody agree? So I want everybody to look at your handy-dandy notes that I gave you on Pythagorean triples. 8, 15, what? 17. Everybody agree? So that length right there would be what? 170. Now look how much easier that is. All right? So 150 and 170 is 320. 320 plus 80 is 400. So you can see, if you know your triples, how much easier that'll make some of the word problems. If you forgot, you would just do what? 150 squared plus 80 squared equals, take the square root, it would be what? 170. All right? Very important. Any questions? Nobody? All right, let's try 61. All right, so for 61, in the right triangle below, how long is AB? Now, do I see anything with 29 or 19? No. All right, plus I'm looking at my answers. Does everybody see my answers here? Right? I'm trying to find a leg. So it has to be, if I label this x, it has to be x squared plus 19 squared equals 29 squared. Does everybody agree? So now, to isolate the x squared, I subtract. So x squared is equal to 29 squared minus 19 squared. And then I do what? Take the square root of both sides. Now, some people think that when you square and square root, if there's addition, they cancel. Do they cancel through addition? Never, ever, ever cancel through addition. So your only possible answer here is what? F. All right, F. Now look, honestly, I feel pretty good about that. Hopefully you feel pretty good about radicals. The understanding is hopefully better. All right, we've done it now for 3 weeks. You should be in pretty good shape. The word problems might be a little bit hard at first, but after I show you, hopefully you agree they're not that hard. All right, so tonight, I really just want you to do or try the what? I want you to try the evens, then we'll come and kind of explain them tomorrow. And then again, guys, I'm just trying to tell you, the end of the 9 weeks is pretty close. All right, this has been a 3-week process. You should be good at radicals. Radicals are on all of your entrance exams. All of your, you've been accepted now to whatever. They're going to make you sit and take an Algebra 1 test to see, and I'm just telling you, you don't want to take Algebra 1. All right, I promise you there's radicals all over the place. All right, on all standardized tests. All right, a big unit. All right, so make sure you have a general understanding of radicals. All right, those things that you don't know, just review. All right, your test is Friday. All right, you're supposed to write down information that you don't know and practice it. All right, because all we're doing on Thursday, I'm not making another review sheet. On Thursday, tomorrow, I'm just reviewing anything you don't know how to do. And you're studying on your own. All right, any questions? All right, keep working.